hyperbola is a set of all points whose distances from two foci are a constant difference. So yesterday, the definition of ellipse was the set of all points whose distances from two foci are a constant sum. Today, it's difference. I'll explain what that means in a little while. Right now, I'll just give you the equations. X squared over a squared, y squared over b squared equals 1, only there's a subtraction sign. Nope, the other side is this, y squared over a squared minus x squared over b squared equals 1. What's the difference between the two equations? I need something more mathematical. Because I can put the x in front. For this one, I could just write it as negative x squared over b squared is plus y squared over a squared. Actually, a could be bigger or smaller in this situation. What matters is which one is negative, okay? So in this situation, the value of y squared is negative. In this situation, the value of x squared is negative. So that's what you have to keep in mind. Whichever one's negative is what really matters. And here's the shape that it makes, okay? What we do is we plot the center at 0, 0. And then what we do is we draw a box. And in this situation, since a is under the x, I move a units in the x direction, and I move b units in the y direction. And I do that all the way around. And I make a box. These graphs have what we call asymptotes, which you've learned about before. They are imaginary lines that the graph neither approaches but never touches, and they go through the diagonals of the box. None of this is actually the graph of the hyperbola. It's just the diagram that we use to construct it. Yes. Because the x squared is positive, this is going to be a horizontal hyperbola. The vertices of the hyperbola are located on the sides of the box. And then the graph goes out and follows along the asymptotes. So the red part is the actual graph. A for the day. Those red dots are the vertices. What is the location of the vertices? Very good. Plus or minus a, 0. They're over a units. We'll also do the length of the transverse axis, and then we'll sketch a vertical one. The length of the transverse axis is the distance between the 2 points, the 2 vertices. Anybody know that distance? 2a. The asymptotes are actual lines, and a line has an equation of y equals mx plus b. For y equals mx plus b, what does B represent? The y-intercept. What's the y-intercept? 0. So we don't need to write anything for B. All we need is the M part, the slope. The slope is the rise over the run. How much do we rise and how much do we run? You rise B, you run A. And the other line is the same thing. It's just negative. So plus or minus B over A times X. That's the equation for the line of the asymptote. Okay. We'll talk about the foci in a second, but let's do another one right now. And the vertical one, A units in the y direction. So I'm going to go up A units, and I'll go over B. And again, I have asymptotes. Go right down the middle. I practice. Just go home and practice. Bought a smartboard for Christmas so I can practice. I got my own smartboard. I orient it whenever I want to. Good for you. Yeah, he's watching it. That stupid teacher. Yeah, he remembers me. Okay. If it's vertical, so that means that the y value is positive, then the vertices sit at the top and bottom of the box, and we draw it again as it approaches the asymptotes. Who can tell me the location of the vertices? You are so smart. Length of the transverse axis is the distance between the two vertices. 2a. Asymptotes. Y is equal to plus or minus something times x. What is the rise? What is the run? A over B. Because one line has a positive slope, the other line has a negative slope. Foci. The foci sit on the inside of the hyperbolas. So much stuff here. I'm going to do my best to draw it. They sit C units away from the inside, just like the ellipses. So in this situation, they sit at plus or minus C, 0. And for this one, they sit at 0 plus or minus C. Now, you need an equation for C. Do you remember the equation for C yesterday? Today, C squared is equal to A squared plus B squared. Just like the Pythagorean theorem. Ah. Oh, whoop. Okay. Let's do it. Let's graph one. What? Yeah, same thing. Center, what's center? 0, 0. How many units could make my box? How many units in the x direction? Dose. How many units in the y direction? Connor wins. Everybody loses. Draw my asymptotes. I have mastered the art of drawing dotted lines, so said by Garrett Motz. Thank you. I have much more confidence now as I draw them. You tell me, does this open up and down or left and right? Why? I tried to trick you here. You look at the bigger number, that's what you did for ellipses, but this has nothing to do with the bigger number. It has everything to do with positive and negative. Look, x squared positive, x squared negative. Y squared positive, y squared negative. You got to look at the value. If x squared is positive, then it opens up side to side. If y squared is positive, it opens up and down. So this thing opens up left and right. So these are my vertices. And this is a rather wide hyperbola. Almost looks like a contact lens or something. I feel like it should be in an eye doctor. I bet you can map the shape of your cornea by a hyperbola. Wow. You guys are supposed to say, oh, that's so cool. Math can be found in everything. Instead, you're like, this sucks. I don't want it. I want math to die. Let's disprove it. Okay. What are the vertices? Plus or minus 2, 0. Excellent. What is the length of the transverse axis? 4. Equation for the asymptotes. Y is equal to plus or minus something times x. What is my slope? What's my rise for the box? What's my run for the box? 5/2. And now your foci. What equation do I use? A squared plus B squared is C squared. What is A squared plus B squared? Which is 29. So therefore, C squared is equal to 29. So C is equal to the root of 29, which is approximately 5.5. Three, 4, 5, 3, 4, 5, 6. I'm going to plot those perfectly because that's the way I do things. Foci have a location of plus or minus the root of 29, comma 0. Isn't that awesome? You could go home and your parents say, what are you doing today in mathematics? Oh, no big deal. I'm just sketching the transverse axis and asymptotes for conic sections, specifically hyperbolas today. And they'll be like, wow, I have a genius on my hands. Yeah, pretty much. So now, remember yesterday I would show you about, well, no, I showed you like the perfect parabola piece, like we could check. So here's what the definition actually means. And I'll just do this once right now. Here's what the definition means. If you take a point on the hyperbola and look at the distance between that point and the two foci, if you subtract those two distances, it will always be constant. So if I selected another point, say, I don't know, this one right here, and I drew it to that foci and that foci, if I subtract the black segments, will I get the same as if I subtract the blue segments? Looks pretty close. Did a pretty good one, I guess. All right. Now you got it. Let's do another one. What do I got to do first? Divide by 36. 4x squared over 36 reduces to x squared over 9er minus y squared over 4 equals 1. You tell me, is this going to open up and down or left and right? Why? Because x is positive. Thank you, Connor. You win. Everybody else loses. All right. You gotta be fast. He's fast. Center, what's the center? 0, 0. Make my box. How far in the x direction? 3. 2 in the y. Very good. Quinn wins. Connor loses. Okay. Now, what should I draw next? Oh, I want Asymptotes. I just want to hear you say it because it sounds so cool. You may also say asymptote. It's up to you. That's why I don't say it. That's why I don't say it. You're allowed to pronounce it either way. Oh. Haley, I'm so sorry. All right. Do the vertices go on the top and the bottom or the left and the right? Left and right. What are the location of those vertices? Plus minus 3, 0. I can draw my hyperbola. You can see that this one is not as wide. It's much more sharply formed. What's the length of that transverse axis? 6. They're not having as much fun as we are. What is the equation for the asymptotes? Y is equal to plus or minus something times x. Thank you. Every time I tell her that, I could hear her, she kind of gets that. Like, that's what I hear every single day over in your room. So. See, now I feel bad because it's as though it's not true. I know it. Okay. Foci, c squared, is equal to a squared plus b squared. If you take a squared plus b squared, what do you get? 13. So therefore, c is equal to the root of 13, which is approximately 3.6. So I'm going to move 3.6 units in the x direction because that's the direction that's stretched. And so my location will be plus or minus the root of 13, 0. Okay, on the count of 3, we'll just, as loud as we can, we'll go, oh! Okay, you got that? Okay, ready? 1, 2, 3. Oh! Okay, turn it over. Cross over 2. Cross off A and B, we go to problem 3. She brought candy for her kids today. She has to, pay them that fun. We just make fun of each other for fun. What? You liar. Oh my gosh. Sounds like a good idea though. All right. I can actually applaud that. I think so. Yeah. She got one yesterday. Don't feel bad for her. Okay. Now we want to write an equation. So just like we did yesterday, we're given the focus is 0 plus or minus 5, and vertices are 0 plus or minus 3. No, we're not doing the 2. You guys basically learned how to do it. So the box goes through the vertices. We don't know how far it's stretched out left to right. We do know that that's the top and the bottom of the parabola, or the hyperbola. We also know that you know, we have foci. Again, we don't know how far it's stretched out, but that's just the general idea of what we know. So I put it visually so we can get a better representation of what it is. I probably have more success moving forward. So you tell me, is this going to be x squared first or y squared first? Y squared over something minus x squared over something is equal to 1. Do we know how many units the box is stretched in the y direction? 3 units stretched in the y direction. So what goes under y squared? 9. Now I just have one last piece to figure out. Do you know what c squared is? C squared is 25 is equal to, because you're adding them together, it does not matter which one is a squared or b squared. For ellipses it does, for hyperbolas it really doesn't. So you just have 9 plus b squared. Either way, b is 4, so b squared is 16, so it goes there. Yep, Pythagorean triple. 3, 4, 5. What I was thinking when I put the problem together. Okay. Last one. Foci of plus or minus 4, 0, and asymptotes of y equals plus or minus 2x. Your answer is right here. That's the equation for the hyperbola. Given the information that we have, can you tell me if this hyperbola opens up horizontally or vertically? Why? Foci are along the x-axis, therefore it opens up horizontally. So this is an x squared over something minus y squared over something is equal to 1. Now, what I'm going to do is sketch my asymptotes. What's the slope for the asymptotes? 2 over 1. So I will rise 2 and run 1. So a lot of people say that my A and B values will be 2 and 1. However, it's not correct. Watch why that is the case. If I go up 2 and over 1, this would be my asymptote box, correct? And I would have a slope of 2 over 1, which it says. But watch what I can do. I could also go up 4 and over 2, and do I still have a slope of 2 over 1? Yeah, or I could go up 6 and over 3, and I still maintain a slope of 2 over 1. So the question is, is it 6 over 3? Is it 4 over 2? Is it 2 over 1? Is it a 1.5 over 0.75? What is it? We don't know. But we do know the ratio. So I'm going to set up an equation where c squared is equal to a squared plus b squared. I know that that's the key. And I know my c squared value. What is it? 16 is equal to. Now, I do not know how far over I go, and I do not know how high I go. But I'm going to use a variable to represent that. A variable that's not already used up here. What do you want to use? Here's a number. Variable. Q? Okay. Q for Quinn. If that is Q, what would the vertical part be? It has a Q in it. QQ, thank you. So therefore, I'll take a squared. So instead of a squared, it will be q squared plus b squared 4q squared. Does that make sense? I squared 2q. 2q squared is 4q squared. 16 is equal to 5q squared. Can I solve for q? 16 over 5 is equal to q squared, so q is equal to the root of 16 over 5. Before you try to rationalize that denominator, just slow down, because we don't actually have to write q. We actually write q squared. Okay? So a little bit more work here. What is the value of q? Root of 16 over 5. So that means 2q would be 2 times the root of 16 over 5. So what I do is x squared over something minus y squared over something is equal to 1. X squared. How far is it stretched horizontally? Root of 16 over 5. Square that. 16 over 5. We'll deal with the fraction in a second. How far is it stretched vertically? 2 times the root of 16 over 5. Square that, you get 4 times 16 over 5, which is 64 over 5. I'm going to make a side note here. Watch so you don't miss this. I cannot leave my fractions as such because that's a complex fraction. So I will simply take x squared over 1 divided by 16 over 5. What happens? You get 5x squared over 16, correct? So your final answer is 5x squared over 16 minus 5y squared over 64 equals 1. I did not give you a problem like that early on. We went through parabolas, we went through ellipses, and then we got to hyperbolas, and the last example pushed your brain a little bit. But I want you to know that the first half of your test will be, can you graph a hyperbola? Can you graph a parabola? Can you graph an ellipse? And if you can do one of each of those, you're going to do just fine. The second half will be a little bit more involved because we're going to shift things around. But that's the focus. Can you, kind of be confident within that skill? Your assignment, very similar to what you had yesterday. There's going to be matching, there's going to be graphing, and then there's going to be right equations. So what I want you to be able to do is this, is when you're working through your homework, realize that for the test, there's 2 really measures to it. Number 1, can you do the problem? 2, can you do the problem within a reasonable amount of time? I have students who take this test, and if they could spend 3 hours on this test. That isn't going to happen, folks, okay? So it's not enough to say, oh yeah, I know how to do it. You need to know how to do it efficiently. That's why you're practicing it. That's why I'm having you graph 4, 5, or 6 of these each time, so you become efficient at it. Where students struggle is they're like, well, I know enough, I don't need to do my homework here. Yeah, I know enough, I don't need to do my homework here. So when they get to the test, they're like, I can do it, I need it, about 2.5 hours. That won't happen. So there you go. Make sure you do some work this weekend.